Hey, hello, hello. So we've
Hi.
got people coming in slowly but surely, about like 42 so far. I think should be anticipating approximately 100 or more. But in the meantime, for those of you that are here already, glad to see you make it. And good morning, good afternoon, or good evening, wherever you may be. So today, for the last session, last but not least, on the last of the first session, we have Bowen, co-founder and CTO of Cizik, and he is going to be talking about hardware acceleration of ZKP. And with that being said, I'll hand over the mic to you.
Yes, thanks. Should I begin now?
Yeah, whenever you want.
Yeah, okay, yeah. Okay, awesome. Thanks, Shumo and the entire Manta team for hosting this talk. It's been a really amazing day, and I'm really thrilled to be here. I'm the co-founder and a CTO of Cizik, and I will be talking about our thoughts and story of building high-performance ZK hardware today. Unlike most of the crypto folks here today, I come from a traditional hardware background. And I'm the guy actually leading the hardware engineering, while my co-founder, Leo, and our primary advisor, Zhenfei, are the crypto guys in our team, which means my talk will be more centered on the hardware side. And I hope this could be an interesting condiment for our community so that you guys can understand what's going on behind your provers. Okay, let's begin. So right now, I think our community will mostly agree that zero knowledge proof is one of the most promising track out there. Many of the layer 1 and the layer 2 solutions are building on top of that and expanding on top of that. And recently, the proof of reserve demand from those centralized exchanges are also rising, and the entire community is calling and watching it. So it's really has been a really hot topic and a track in our community. And however, one thing that we found that really prevents ZKP from getting even widely adopted is the performance bottleneck. We did some performance-oriented profiling on some of the most popular proven systems on the market, for example, Halo 2, Rapid Snack, Hyperplonk. And we found that MSM, short for multi-scalar multiplication, and NTT, which is short for number theoretical transform. Those two components are the two biggest common performance bottlenecks across different proven systems. Of course, the exact number will vary with different proven systems. For example, as we see, 60% of the execution time goes to MSM, and about 10% to 15% goes to NTT for Halo 2. But if we speak about Hyperplonk proof system, the distribution will change to about 40% goes to MSM and another 40% goes to MLE for the Hyperplonk. But the general takeaway message is that about 80% to 90% of the entire prover execution time can easily be migrated to use hardware acceleration and can be drastically increasing its performance. And we realize that the community will need ZK hardware in near future, and there will be value in it during the summer. So we decided to found a company and start to raise money to run this as our main business. However, there are multiple design choices exist for ZK hardware, FPGA, GPU, and the ultimate ASIC. A lot of VCs and PEs have been asking this question. A lot of projects from the community have also been asking the same question. FPGA, GPU, ASIC, which one is better eventually? To be honest, we had no answer to the problem at that moment during the summer. But we do believe that the short-term and the mid-term competition will be primarily just between FPGA and the GPU. And ASIC will decisively win the whole market in the long run. Our team expertise was strong in FPGA and ASIC. So choosing FPGA and ASIC become our natural choice. But the problem lies on the funding when we talk about the ultimate ASIC solution. We all know that ASIC tape out is really, really expensive. Easily tens of millions of dollars go into toilet if you don't handle that carefully. So our strategy is that we can build FPGA prototype system as the first step to test our design, our capability, and our hardware supply chain behind us. And then we can use this to convince the market and the investors and our potential customers to see that we are ready and capable to throw like tens of millions of dollars into the actual development and the building of the ultimate ASIC solution. Therefore, we formed a team with just 5 people by the end of the summer and started to work on the first generation FPGA-based MSM acceleration, while at the same time preparing the future expensive ASIC tape-out. So next slide. So we complete our first generation MSM acceleration design by the end of October with a lot of optimization in the hardware pipeline and still rapidly evolving at this moment, even at this moment. It's a fully pipeline architecture, which means it can absorb input data without any stores, which is really good for software developers. And one such pipeline will form a PE, which is processing elements, which is short for, and one such process element is enough to handle the entire MSM operation. But if we can distribute the input data into multiple PEs, we can do parallel operations, and the performance also grow linearly with the number of PEs in a PE cluster. So for the hardware, we choose a special packaging version of VGA chip from Xilinx. The PCB board is also highly customized to provide stable power delivery at higher frequency. And also we managed to run the entire design at 300 megahertz. And the results look pretty good. We publicly announced the result at the end of October at the Berkeley Zero Knowledge Proof workshop. I believe many of you have been in the workshop as we did. It seems to be the most powerful FPGA acceleration design on MSM by far, about 5 times faster than Pipe MSM and 2 times faster than Cyclone MSM. It was greatly welcomed by investors and the community. We received far more term sheets and investors than we did during the summer. So it's a great thing. So we began to in close contact with the amazing Manta teams, and that's pretty much the reason why we are here today. And our team was greatly encouraged by this announcement, but at the same time, we are fully aware that it was announced before the price, and we are aware of the fact that some of the strongest competitors haven't announced their results yet. And we believe some of the competitors do not even participate in the Z price at all because they do not want to open source their design. So it was still a really challenging problem to see how FPGA compared with GPU in terms of performance, power, and price, and how we can catch up and surpass the performance of Z price winners. So after some competitive analysis, there we go. So it turns out our first generation FPGA solution is still far from SuperRational's open source GPU solution, to be honest. And let's take a look at the table. It shows the performance comparison. As you can see, our first generation design is about just half the performance when compared with a 1380 Ti GPU with a SuperRational's open source solution running on top of that. And when it comes to the latest generation of GPU, which is 1490, we are just about 1/3 of performance. And that's really an alarming call. And it's not just us. If you look at the entire performance chart from the Z price, you will notice that the entire FPGA track of Z price is generally about 2 times slower than the winners from the GPU track. So after that, we received many more questions from the market. Is that they're wondering, is FPGA still competitive against GPU at all? So we have been working extremely hard on the next generation design since the October announcement, and we do believe that the answer is still yes. So the currently ongoing next generation design, we call it Mars MSM. It's based on a whole new customized FPGA accelerator card with our customized SerDes interconnect between multiple chips on board, and also a customized PCIe interconnect between the main CPU and our FPGA accelerator cards. And one notable thing is that this is a MSM and NTT unified solution, which means we will be running MSM, NTT, and NTT on the exactly same hardware. And we will be using this Mars MSM to compete with top-tier single GPU solution. And on top of that, we have a massively connected FPGA system. We call it Solar MSM. It's our trump card against top-tier multi-GPU solution on the market. It's also an MSM and NTT unified design. It has customized rack-level thermal solution, and also rack-level power delivery to unleash the full performance of our design. And our entire hardware is packed into a high-density chassis, which is about 50% to 75% of the size of a typical GPU server. And we will be using this Solar MSM system to compete with top-tier multi-GPU solution. So how about the performance of our next generation FPGA server for the ZKP prover? We believe the competition among ZK hardware will be escalated to be between massively connected GPUs and massively connected FPGAs, starting from just next month. We anticipate there will be more than a couple of highly customized GPU servers and highly customized FPGA servers on the market by the first quarter of 2023. And we are prepared for it and are thrilled to join this battle. So as you can see from the table, the Z prize winner from the GPU track has about 3 times to 7 times higher performance than our first generation design, which seems to be a really daunting gap. But our Solar MSM system will be taking the performance leadership back with about 8 times higher performance than the Z prize winners. And it will be literally a monster machine. We want to inject confidence into the market to show like what ZK hardware can do and what our team can achieve in a couple of months. The physical hardware design of the Solar MSM system is already completed last week, and it's already in the fab for the final manufacturing. We will be delivering the first Solar MSM server to our customers and potential customers for a trial run next month, which is January 2023. And we are still working on getting more optimization deployed in the Mars MSM card and also the Solar MSM system to make it even faster. And we are discussing about possible conditional open access to the public after the trial run with our customers and potential customers. So everyone can witness the monster performance of the Solar MSM system. So as we mentioned earlier, our efforts on FPGA prototype system is actually paving the way for our ultimate ASIC solution. So we are happy to share that currently we have more than 10 engineers on board already, and we are working towards a 12 nanometer ASIC design. As you can see from the preliminary layout of our final chip on the right-hand side, that the performance we expect from the ASIC chip is that it can compete with top-tier multiple GPU solution with just a single chip. And if we can connect several such chips together, it will be deliver crushing level performance when it is fighting with a top-level multiple GPU solution. And it's also a MSM NTT all-in-one design. And we'll be having about 5 to 10 times higher energy efficiency. And if we can ship the chips to the community in large volume, we can shop the price to be just a fraction of what you guys can see from a typical GPU server from the market. So our final architecture will be a fusion of FPGA and ASIC, because we do want to have the highest level of programmability of FPGA so that we can deploy some project-specific operations on FPGAs. For example, the witness generation procedure for Halo 2. And we can also deploy the common operations such as MSM and NTT onto our ASIC chips so that we can deliver highest possible level of performance and energy efficiency to all the proven systems. So here is the status of our current team. Me and Leo are the 2 co-founders of SciSig, and Zhenfei is our primary algorithm advisor, and we're the guys running in the foreground. And on the background, we have a 10% engineering team, and I'm also doing coding with the team as well. And much of the work that we presented here today actually should be credited to the background engineering team, and they're just awesome. We will be quickly expanding the team to be around 15 engineers in the first quarter of 2023 to prepare for the 12 nanometer ASIC tape-out. So as a final wrap up, the takeaway points are that the hardware acceleration will be a really helpful boost for high performance proven system. You guys can see 10 times or even 100 times higher performance when you guys are running on a specialized hardware for MSM entity and other operations for a ZK prover. And our solar MSM FPGA system will achieve approximately 1 second for 2 to the power of 30 MSM operation by the first quarter of 2023. And our 12 nanometer based ASIC chips will hit the market by the first quarter of 2024. And welcome to follow us on Twitter and Telegram. And here are the QR codes for our Twitter accounts and also our Telegram community channel. And also welcome to send us your questions and requests for information sharing through email at info@scic.xyz. Yeah, and that's all for my presentation. And will be happy to take more questions. Thank you, guys.
All right, thank you, Bowen. I think we've got some time for questions this time around because we're going into a break, but also amazing presentation, got a lot of interest from the community. I saw the first question that was actually in the comment section, so I just moved it over to the questions. But the first one is, what clock speeds are you running these FPGAs at for your results? Is there any overclocking happening?
I would say yes. So overclocking is part of our design because if you want to survive from this fiercely competitive market, you have to squeeze out every single bit of performance out of your hardware. So, and that's why I just mentioned we customize our PCB board and our entire rack level power delivery to make sure that our chips can run at higher frequency so that there won't be power integrity problem for the hardware. Yeah.
Got it. Thank you. And is communication really a bottleneck for MSM?
Yes, definitely. And that's the reason why I also mentioned we also customized our FPGA interconnect between between the CPU in our system and also our FPGA accelerator card cluster. Yes. You need to boost the performance for the PCIe interconnect. Otherwise, you won't be able to get the same level of performance. Yes.
Got it. Okay. And final question is, how do you compete with an NVIDIA RTX 4090 graphics card?
Yes, that's a very good question. So as you can, let me go back to my previous slides. So as you can see, our first generation design, it's about 3 times to 7 times slower than 4090. So it's really a daunting gap. So we found out that if we push the design to the limit with higher level of customization with our board, with our FPGA chip, and also running all the hardware multipliers at a higher frequency level and higher utilization level, and we can connect multiple such FPGA cards to form a massively connected FPGA cluster. As you can see here, we are expecting a 8 times higher performance than what you can see from a single 4090 GPU. So that's our answer to the problem. Yeah.
Awesome. Thank you for that. And thank you for the presentation overall, Bowen. I think that was amazing. I think there's a lot of things that we're going to be taking into consideration over here at Manta based on your talk as well. So audience, right now, what we're going to do is I'm going to move us into the break session. And we're going to play a little game before everyone goes on break. We are approximately 10 minutes behind. But after the break, which will shorten to about 5 minutes, we'll start with session 2. And you definitely don't want to miss session 2 because we've got a lot of amazing speakers coming on as well. First, we'll have Todd from Manta Network, and then we will have Sebastian Loduca from ZK, or he's a ZK researcher, talking about Ponte 2. And then we've got Brian from Risk Zero, Wei Dai, a cryptography researcher formerly at Bain Capital. And then finally, we'll talk with Rahul from Jump Crypto. So with that being said, I'm going to end the session here. Thank you again, Bowen, and we will move into the break session and have the